All right, welcome to a Math Minute with Mr. Larson. Hopefully having a magnanimous day and hope all goes well with what we're about to talk about for a few seconds. This video assumes that you already know about probability and that you already know about probability of independent events, where you have one event that occurs and then another event that occurs and you multiply them together, the probabilities, and they don't have anything to do with each other. You just find the two events and multiply them together and find the probability of those two things happening. So assuming you understand that, we're now going to talk about compound events that are dependent, where one is dependent on the other one. They're not independent. They're actually tied together in some way. So get me out of the way, and I'll show you what I mean. When you have two actions that are going to happen, compound dependent events. Let's say in picking marbles from a bag, let's say what's the probability of picking a green marble, and then you're not going to put it back, and then picking a blue marble, where this action, the second action, is dependent on what happened before. And here's what that means. First, find the probability of getting a green marble, and you can see that there's 5 out of 20. Pause if you want to count. And then finding a blue. Well, we've already taken an action. We've taken a green marble out of the bag. So now there's not 20 anymore. We can't use that 20. Blue, 1, 2, 3, 4, 5. There's 6 marbles out of, and as we count them up, we see that because we've taken one, 19. This number's less because it's dependent on what has occurred on this first one. The calculator does the rest. When you multiply that out, you get that it's 20 over 380, and your calculator will give you what the decimal is of that if you want to find the decimal. 20 over 380, 1/19th, or 0.053 if you want to round it to the nearest thousandths. I could find the probability of getting a red one and then another red one, for example. And let's say that green one's back in there. The green one is now there. We got 1, 2, 3, 4. There's 9 red out of 20. And let's say we pull that red one out. And then the next red one, well, we've gotten rid of a red one. So now there's 8 red ones left out of 19. You can see how in these events we're choosing, they're decreasing if they're the same one. So multiplying those out, we get 72 over 380. Higher chance of getting 2 reds than up here, you can see. And 72 3/80ths, 18/95ths, and that becomes 0.189. And it goes on from there. All right, and you can see this happen no matter what the amounts are. It's just a matter of finding the probability of the first item. Let's say I like oranges. What's the probability of getting an orange and then an orange? Well, getting the first orange, there's 2 out of these 8 pieces of fruit are oranges. And then after I've taken one, I now only have 1 orange out of 7 left. It gives me 2 56ths or 1 28th, or to finding the decimal, about 3%. If I round it to the hundreds, 0.036, I'm running to the thousands, 3%. Well, what about getting the probability of getting an apple and then an orange? Let's say orange is in there, so the first one is 6 out of 8. And then on the next one, let's see, the apple's gone. So now there's 2 oranges, if I'm doing the starting over, 2 oranges out of 7. So I'm at 12 56ths. And my calculator knows that 12 56ths is 3/14ths, or 0.21 on for a long time. And that's what dependent events are, is where the second fraction, the second probability, takes a little bit of work to find because we have to find it with the new reality that depends on the old one. What if I've got 10 socks in a drawer? And I want to know, well, what's the probability of getting a matching pair of black socks? And then later I'll do, what's the probability of getting a matching pair of white socks, for example? Well, the probability of getting black socks, there's 6 black socks out of 10. And then that second black socks, if one of them's gone, there's now only 5 black socks out of 9. Which gives me 30/90ths, and your calculator will reduce that to 1/3 or 0.33333 on forever. I've got a 33% chance when I pull out 2 socks one at a time that they'll be matching black. Well, for matching white socks, I can see there's 4 white socks out of the 10. And that second white sock, if one of them's gone, I can now only get 3 white ones out of 9 remaining. And that gives me, let's see, 12 over 90. And that reduces to, is it 3? No, 4/30ths. That'll reduce again to 2/15ths. Just to show you what I did, 12/90ths. 12/90ths. And as a decimal, we've got 0.13 on forever. So on these dependent events, that second probability changes based on what we did the first time. So we've learned before about independent events. There can also be dependent events where it's a little harder to find. But you got it. Two fractions, 2 probabilities, multiply them together. Just do the work to find the second one. Thanks for watching. Hopefully it was helpful. Bye-bye.